this out. I'm sorry that the screen... Hey guys, I just thought I'd post a video real quick to have something that you could watch to see how to do a stoichiometry problem step by step. I'm going to work through this two ways. The first way I'm going to work through it is going each step getting a completed answer. Then the second time through, I'm going to show you how to do it where you set up that bridge notation. Okay, so when we look at our problem that I have here at the top, it says how many grams of carbon dioxide are produced when 2.50 grams of sodium hydrogen carbonate, that's another name for sodium bicarbonate, reacts with excess citric acid according to this equation. So guess what? Right here, this equation they gave you is already balanced. If you refer to your note card, step 1 says balance the equation. Well, step 1 is done for us. Step 2 says to know what you are given and convert to moles if necessary. Well, we're given in the problem 2.5 grams of sodium hydrogen carbonate. That is this substance right here. So just like I did in class, I want you to write 2.5 grams right underneath that. We are also asking how many grams of carbon dioxide are produced. So that's going to be over here on the right, and we want to put a question mark with grams there so we know what we're given. Now, because this problem gave us this amount in grams, we do need to convert to moles. And let me remind you that you convert to moles by dividing by the molar mass. So we're going to start with 2.50 grams. And we're going to divide by the molar mass of sodium bicarbonate. Well, the molar mass of sodium bicarbonate, I'll put over here. It's going to be 23 plus 1 plus 12 plus 48. I got the 48 by multiplying 16 times 3 because each oxygen is 16 grams and we've got 3 of them. We add this up, and when we do, we get 84 grams. So that's what we're going to divide right here by. When you divide 2.5 by 84, you get 0.02976. Since we're doing this step by step and getting an answer, we want to keep a good amount of the digits. We will simplify to significant figures as our very last answer. Okay, but at this point, step 2 is done. You're now going to want to do step 3. Step 3 says multiply by the ratio of the coefficients. Remember, this is your mole to mole ratio, and we're only going to want to be dealing with the 2 elements that our problem asks about. So we're going to take our answer from number 2, 0.02976, and we're going to multiply by this ratio. Now, mind you, the units that we're in here are moles of sodium bicarbonate, sodium hydrogen carbonate, same thing. So we're going to want to make sure that when we multiply by the ratio, we put the coefficient of sodium bicarbonate in the denominator. So we'd have 3 sodium bicarbonate on the denominator, and we'd want the element that we're going to as the numerator. So that would be 3 CO2 or carbon dioxide. The reason there's a 3 as both numerator and denominator is because that's the coefficient of both of those elements in our balanced equation. Well, when we multiply, you guys, here we go. When we multiply this out, 3 over 3 is just a 1, so you're still going to end up with 0.02976. But now, because our moles of sodium carbonate cancel out, you've got moles of CO2. At this point, step 3 is done. Step 4 asks you to convert to the units requested in the problem. Well, if you look back up at our problem, the beginning of it asks how many grams of carbon dioxide are produced. Grams is your unit of mass. We're being asked to find the mass of carbon dioxide. So we have to take our moles, 0.02976 moles of CO2. And in order to convert from moles back to grams, we now have to multiply by the molar mass. This time it's the molar mass of carbon dioxide, which is going to be 12 plus 32, or 44 grams of CO2 in 1 mole of CO2. This way our units cancel out. And when we do that, we're going to get an answer of 1.30944 grams. Now that we're done with all 4 steps, we can look at our significant figures. We started with 3 significant figures in our problem, so we have to go to 3 significant figures there, which means our answer will be 1.31 grams of CO2. There's our answer. Okay, so now if you were wanting to set this up in bridge notation, it's simply taking each step as a separate section of that bridge. So it's going to look like this. So step 2 is divide by the molar mass. So you'd have 1, I'm sorry, this one is supposed to be grams. I got going fast. This is supposed to be grams of sodium bicarbonate. So you'd have 1 mole of sodium bicarbonate over 84 grams of sodium bicarbonate. That's your end of step 2. Step 3 is to multiply by the coefficients, or the mole-to-mole ratio. So you'd have 3 moles of CO2 over 3 moles of sodium bicarbonate. And then to convert to the units requested, which would be step 4, your last fraction then is going to be your molar mass of CO2 over 1 mole of CO2. And then when you plug that into your calculator, what I would do is I would show that 3 over 3 cancels to a 1. All my units are canceling out. Grams of sodium bicarbonate, moles of sodium bicarbonate, moles of CO2. I'm left with my grams of CO2, which is what I'm wanting. I would then plug into my calculator 2.5. I'd say divided by 84 since it's in the denominator. And then I would times by 44 since it's in the numerator. and I end up with exactly the same thing as I ended up with at the end of step 4 previously. When put to significant digits of 3 significant digits, I get an answer of 1.31 grams of CO2. So either way that you want to do this problem is fine. If it's easier for you to set up bridge notation, by all means, I encourage you to do that. If it's easier for you to see an answer at the end of each of the stoichiometry steps, that is completely fine too. In class, you will see me use bridge notation just because it's simpler and more concise and neater to see. But by all means, either way works. All right, I hope you guys are having a great weekend. I look forward to seeing you in class either tomorrow or Tuesday. We'll be practicing some more of this stoichiometry to make sure that you all feel confident with it. Love you all. Bye.